All right, hey everybody. Today we're going to be doing Leetcode 128, longest consecutive sequence. And this is a medium problem. Given an unsorted array of integers, nums, return the length of the longest consecutive element sequence. And the algorithm has to run an O of n time. So if we have our example here, we can see that nums are these numbers, and the longest consecutive sequence would be 1, 2, 3, and 4, right? So basically, the array is not in order, and we need to find the largest group of numbers that are all separated by 1, right? The largest group of elements that are all separated by 1, but they don't have to be together. So to think of not even a brute force solution, but one that would just work, would be to sort the array, right? So for example, if we sorted the array in example 1, we would have 1, 2, 3, 4, 100, and 200. And if we had something like this, we could go through the sorted array. Let's just start at 1, for example, and see if the next element is up by 1. And then we could just keep a count of the max seen. And as we go through the array, we can update this max seen as the condition holds true, and we would have a simple way of finding the longest consecutive element sequence simply because of the array being sorted. Unfortunately, the array is not sorted. So this is the first thing I would think of. Unfortunately, sorting an array takes O n log n time, so any solution involving sorting the array will definitely be too slow. So how do we get something that runs in O of n time? And there are a couple of things to keep in mind here. First, we're working with an array, and we're also working with sequences. So with arrays, a lot of these O of n algorithms involve two pointers, and some common two-pointer solutions are the fast and slow and the sliding window. Now, would any of these work when it comes to this problem? And I'm just trying to walk through the thought process. Obviously, I know the solution, or else I wouldn't be making this video. But what are some of the tactics we might approach when approaching this problem for the first time? And if you're thinking O of n and you're thinking two pointers, I mean, that's a reasonable guess, right? And the problem with that is that two pointers is usually a lot more useful when you have a sorted array, because a sorted array gives you a lot of options to move the pointers. There's a lot of conditions you can use to move the pointers as we make the problem set the size of the problem smaller as we move throughout the algorithm. Unfortunately, since the array is not sorted, it doesn't really seem to have that effect. And I also don't see how fast and slow pointers would give us a sequence, especially considering that the array is not sorted. So two pointers is out. I don't think there is a way to use two pointers for this problem. Now, another thing we can think of is a hash map. Now, why do I arrive at hash map? Well, because it's another common solution practice pattern that happens when it comes to these arrays. And a hash map is actually the way to solve it. But even knowing that the hash map is correct, how would we use the hash map? Well, let's make the key realization for this solution, right? Let's say we had some magical function that could figure out the starts of every sequence, right? That could figure out the starts of every consecutive element sequence in nums. So it could just give us, given the example in nums, or example in example 1, we could have it give us 100, we could have it give us 200, and we could have it give us 1, because these are all the starts of the consecutive element sequence is in nums. All the consecutive element sequence is in nums will start with either 100, 200, or 1. And 1 is the only one that extends for more than one element. 100 and 200 both end right there, but 1 goes to 2, goes to 3, and then goes to 4. How do we know what the next element in the sequence is? Well, the next element is obviously just going to be the previous element plus 1, right? So with that logic, is there a way we could find just the starts of every consecutive sequence in nums? And the answer to that is to use a hash map. Why? Because for every start of a sequence, it holds true that that element, so for example, the sequence of, say that start of the sequence n, right? N minus 1 is not in the array, right? If n minus 1 is not in the array, is not in the input, that is the start of a sequence. And with this intuition, we can quickly develop a way to find the longest consecutive element sequence, because at every start of the sequence, we can just go ahead and count with this method, right, and see how long the sequence is. And if we can figure out how long each of these sequences are, then we can find the longest sequence, right? It's fairly trivial to do. Now, the key realization to make is that membership can be done in constant time, and therefore we can fulfill our time requirement of O of n thanks to the fact that checking for membership in a hash map or a hash set, it doesn't have to be a map. We don't have to map anything here. We just have to figure out whether this element, for every element n, whether n minus 1 is in nums. If it is not in nums, that means we have the start of a sequence and we can start counting. Once we start counting, we can figure out the length of every sequence, and in linear time, in O of n time, we can go ahead and figure out our longest sequence. So let me just write some pseudocode. So we're going to iterate through the array, and let me just go ahead and use the semi-Python way of doing it. Okay, so for every element in nums, if nums I minus 1 in a set that we make of nums, so let's go ahead and make that set. So I'm just going to do it here, right? Like, I'm just call it a set is equal to sets of nums. And then we'll go ahead and call this the set. So if it's in the set, then we start counting, right? And the longest one, the longest sequence is the answer, right? Okay, so with this intuition, we're able to solve this problem. Again, I want to note here that it is a bit of a gimmick problem in terms of the fact that it doesn't really go along with any pattern. You just have to realize in an interview or in an on-the-spot situation that you would be using a hash map, and what would be really useful to have in terms of solving this problem. In this case, it's the knowledge of what the starts are for each sequence. And if you were to categorize this problem, you could say it's a hash set problem, hash map problem. Two are basically interchangeable, but really it's a graph problem. You can think of the starts of the sequences being, the starts of a graph, right? So for example, 1 to 2 to 3 to 4 is our graph. 100 is also part of our graph, and these are not connected, but the rest are directional. And we just have to find the longest in the longest chain of nodes in our graph, in our directed graph. But to be honest, that graph explanation doesn't really hold up here because there's no search, which is what we're usually doing with graphs. So honestly, just think of it as a clever way to use hash maps. So, okay, let's go ahead and code our solution. So first things first, we want to make a set, right? The set is what allows us to do this algorithm in O of n time. Now, if you don't remember how to do this, you can obviously just make a hash map, which is a dictionary in Python, and you can do a very similar thing. All we need to check for is membership, because for n in nums, so for every element in nums, we're going to go through and we're going to find these starts. Remember, only when we have the start can we count how many elements are in the sequence, right? So when we're at the start of a sequence, we want to count how many elements are in the sequence. So find the starts of the sequence. So here we're going to see if n minus 1 in nums of set. And actually, it's when it's not in the nums of set, it's a sequence, right? For example, if there is no 99, we know that 100 is the start of a sequence. Now, why are we even counting 100? Because there is no sequence after that. Well, it's just the fact that the length of the sequence is 1. We don't know what the length of the sequence is, we just know that it's the start of a sequence. And if it's the start of the sequence, it could be potentially the longest consecutive sequence. So if we were at 1, we know that 0 is not in nums, for example. So we can just keep counting 1, 2, 3, 4 and have our longest consecutive sequence. But we don't know that. We just know that we're at the start of the sequence at this point. So if we're at the start of the sequence, how do we count the length of the sequence? And there are various more messier ways to do it, but I think the cleanest way is to have a little counter. So let's call this counter cur. We're going to set it to 0 at first, all right, or even 1 at first, okay? Doesn't matter. So if while the n plus cur in nums of set, and you can see why the set is so useful here, right? Because this takes constant time. It takes O1 time, basically, right? So it's very fast to do this. Now, if we were to use an array, for example, it would take n time each time we want to see whether n plus cur is in num set. So it's good that this takes O of 1 time. So while that's true, nums, we're going to increase our cur plus equal to 1. And obviously we have to keep track of the longest sequence we've seen so far. So we can go ahead and make a result variable. This is going to be our answer. This is what we return. And remember, it's an integer. And we're going to go ahead and we're going to set the result to equal to the max of the current result and whatever we got for cur. Because you can see as cur goes up, we are basically going to keep counting, right? So if the length of the current sequence is 1, well, now we're going to be at 2, and then we're going to check whether 3 is in here. And all the time we're increasing cur. So once we get to 4, we know that our sequence is 4, and we're going to max it with our res and see whether it is the answer, which it is in this case. So we're going to return that, and we're going to run and see if this works. And remember, all the code here is just counting how long the sequence is. You can do it a variety of ways. If another way makes sense to you, go ahead and do it. It's up to you how you want to do it. But yeah, we have gone ahead and passed the easy test cases. So we're going to submit and see if we pass all the test cases, and still judging. And yeah, we did pass. All right, let's say we didn't just want the length of the longest consecutive element sequence. Let's say we wanted the actual sequence. Like instead of this being the length, just have the actual LCS that is what we want, okay? So how would we do this? Well, we could make this set into a map, for example, and then just instead of just counting here, we could actually store the sequence in the value of the map, and that would work. But there's an even simpler way that doesn't require changing our solution much because of the properties of a longest consecutive sequence. Remember, in a sequence, the consecutive element just goes up by 1. So if we know the length and we know the start, we can also output the sequence. So instead of just having our result be 0, we're going to also keep track of the max start, right? And then we're going to have this be 0 for now too. I think it makes sense and that will work. If we go ahead and now also keep track of this max start, so if cur, so this is going to be the index of the max start and the length of the LCS, okay? So if cur is greater than result, okay, we're not only going to do this, but we're also going to keep track of the max start. Max start is going to now equal to what? It's going to be n, right? Because n is the start of our current LCS, the LCS that is the longest so far. So instead of returning results, we're going to make an array. Given that we know the start and the length, we're going to say, okay, how about, we can call it whatever we want, I for I in range, max start to max start plus res, okay? And then let's see if this works. Oh, well, it won't work, but you can see that it is giving us the correct answer for the test case. So in this case, it'd be 1, 2, 3, 4, because the Leetcode checker will not really know what we're trying to do here. But if we do this, for example, it should always give us the right answer. And yeah, if we submit it, it would work. This is how you would do it if you actually wanted the sequence itself, not the length. So I hope this helped.